Hi, welcome to a new video. As promised, today is when I will explain how my serial data transfer system works. So I have here the transmitters and the receivers. So this video is going to be divided in two different sections. The first one is for those of you who just need a quick tutorial on how to build this thing, especially focused on those of you who are revisiting the video. And the second one is when I will explain how to adapt the system, basically by expanding it, turning it into a 2 or 3-dimensional system, as well as talking maybe a little bit about the bugs that I found, and explaining how the second example that I gave you in my previous video works, because it seems like this is the example that you guys are mostly interested in. So, without further ado, let's start. As you can see, we have two different systems in here. So the blue one is what I consider to be the most practical one, and the red one is more of a proof of concept. They are completely silent and they don't use any pistons. And one of the reasons for that is because they send one bit every tick, which means that if you want to send a pattern like this, for example, let's send it to the other side. You can see it's already there. The information is not going to be sent like this, so off, and on, but rather like this, meaning all the bits are merged into a single pulse, if you will. So for instance, if you have to send information like this, it works pretty much like a 4-tick pulse being sent through a single repeater. The receiver never knows when the transmitter wants to send anything, and this is why we need one extra bit called the synchronization bit, to awaken the receiver so it knows that the next ticks are going to be followed by bits that it needs to store. Otherwise, it would think basically that the transmitter is sending a constant flow of zeros to this side. So in this example, we have 4 bits to send, 4 bits of data, and it's going to send one extra bit, almost like it has something like this, a constant 1. So when I press the button, the 1 goes in and the rest of the data goes follows it. So it just requires one extra bit. This circuit down here sends 3 bits of that data followed by, 3 bits of synchronization followed by 4 bits of data. And because of that, the circuit that receives the information is a lot simpler, as you can see here, if you compare the two of them. And just as an extra example, because of the synchronization bits that we send, we are actually able to send a completely zero that's different from this complete state of zeros here. If you look back there, it's now all zeros. In general, I would say the red circuit is better if you need to send frequent small chunks of data, and the blue one will be able to send larger quantities of bits at the same time, but less frequently. Let's start with the red circuit. So this is going to be the transmitting side, and the receiving side is going to be that one. So I like to set the bits using levers like this. So we also need a button to send the data when it's finally configured. So we start by placing torches on the back of all of those, and on the data section you place hoppers on top. And then on this direction, opposite to the input, we place observer blocks, and then connect those observer blocks like so. I think on editions of Minecraft that can't read observers from other observers, you can probably do something like this. I'm not sure, you would have to try it. I don't play on console, so unfortunately I can't test this for you. And so hoppers are silent, and they have the added benefit of letting you put redstone dust on top of them. You don't need a repeater here unless you're going to expand the number of bits you want to send to the other side. So here we just need this line like so. And now let's take care of the input. The input doesn't actually need a lamp because this lamp's always going to be turned on. Okay, so we have something like this, and we need to do it like so. So everything gets powered here, and here we need still another hopper that's going to be powered all the time, and then we connect the observer block to this guy, and that is your transmitter. You can take an input anywhere on this line, so for instance from here or from here, but make sure that whatever comes out of this redstone line is always set on 1 tick. Time to work on the receiver side. Okay, so let's start by placing redstone dust on top of these blocks and then repeaters in between. And those are just indicators. They are very useful for debugging, but they are not actually needed. You can use solid blocks in here. The thing you cannot do is to have solid blocks in here to be cheap on redstone dust. And the reason is the game has, unfortunately, a bunch of bugs that Mojang apparently insists in not fixing. And because of that, some things become very sensitive here, like you need to have redstone dust, unless data will merge sometimes and will not be able to decode the input. Because remember that data is not sent like this in small pulses, it's sent all merged, and in order to be able to split the bits again, we need the redstone dust there. Don't ask me why, this is just how it is. I made sure to run a bunch of tests on this thing. So basically I built all of those circuits in all directions, in different locations, negative coordinates and everything, just to make sure that you get a stable circuit. So please make sure to follow all the instructions, and this is going to be the difference between a working system or a headache. Okay, so let's start with the fixed, or the system that's not ever going to change, which is this section here. So here next to this block in the middle we have another block, so remember that we have 2 blocks here, and next to this we have a comparator that must be on subtraction mode. Place redstone dust here and connect those. So I know, guys, it's a little bit of a waste with the signal strength, to be honest here, but it doesn't matter since this one is just a proof of concept kind of circuit. Alright, so for the input we just we need a repeater. Actually this needs to be redstone dust, guys, sorry. We repeater on 1 tick, repeater on 2 ticks, and repeater on 4 ticks. And redstone dust in here. Actually this repeater can go in there. So I will give you a good look in here so that you can see what's going on here. And remember that we have repeater on 1 tick, 2 ticks connected to the comparator, and 4 ticks. So this is the base system, and this is going to be the official input that we can connect to the transmitter. So yeah, make sure that your redstone signal is going to reach where it needs to be. Just make sure, I like to add a repeater here before the beginning of the circuit here. So to configure the system, so you need to power this line. It's not strictly necessary, but it's good to be powered here. This is going to be powered forever until it senses that something's being transmitted. And now it's the configuration bits. It's pretty easy. If we're going to transmit 3 bits, you just need to add 3 ticks. So 3 ticks like so, and connect this. This should be ready to work. For instance, if we're going to transmit 7 bits, you could add 4 plus 3, which is 7, and then just connect all of those like this. And this is a setup for 7 bits. Of course you will need to extend this side as well. So let's set it back on for 3 bits and run our first test. So I'll just maybe set the bit in the middle and try to transmit it, and it works. Maybe let's try the opposite of this, and yes, it's working properly. Time to work on the blue circuit. Okay, it's very similar to the red one, so I will just modify this one. So we can destroy those blocks. And remember that we have the torch there. So maybe let's start by placing a furnace, and you need to place a furnace inside. It can't be any item. This is the most stable item in the game, so you have to place a furnace inside. So here is where we have a comparator. It can be on subtraction mode, it doesn't matter. So here we also need a slab, but first let's extend this line. redstone dust, you place a torch, and this is the reason why we need a slab in here. So down here we can place another hopper, observer block facing up with a solid block, and now 2 repeaters. They are both set on 2 ticks like this, so this is pretty easy to modify. And now this block doesn't do anything, so we also have to shift this thing to the side. Alright, so this should be all for the transmitter. And now for the receiver. Once you have the same setup in here, we can get a little bit closer using this solid block in here, and it's side by side with this other guy, another solid block, and this is going to be your latch. So we need redstone dust in there, and a repeater, solid block, 1 tick here, 4 tick on the sides, 4 ticks on that side. So I'm giving you this view that you can pause the video and check your build now. And we just need to do the same thing now. So if we are using 3 bits, we configure the next repeater to be on 3 bits as well. So now we just have to connect this to the input. Make sure to not do something like this, for instance. So yeah, it's going to break the system. We can also power this line if necessary. Oh, I clicked this one. Those things need to be on 1 tick. Please don't mess this up like I did here. Okay, so let's test maybe transmitting this thing to the other side. And it works. Let's transmit the opposite. Okay, and let's now clear the device. Okay, so these are the serial transmitters and receivers. In case you need in case you want to have a transmitter and his receiver on both sides, I also came up with this recently. This is so simple and I've never seen it, but I'm sure someone else probably came up with this in the past, but I've never seen anything like this. It's a 2-way repeater. If I can remember how to do it, yes, I think it's solid block goes like this, and then this solid block like so, and then actually you have it like this, I guess, yes, like this. This is a pretty amazing 2-way repeater. So yeah, just to show you that it works on both sides, and you can transmit 1-tick pulses. You can hook up a fast clock to it, and you can also transmit 0-tick pulses. This one, which is what I use most of the time, unfortunately I don't know who created it, and I think it's something like this. No, a little bit confused. Yes, like this. Subtraction mode. Alright, so yeah, this one is what most people use, but this one will not transmit 0-tick pulses. Of course, it will convert the 0-tick into a 1-tick, but it won't transmit anyways because of the comparators. And this one also adds 2 ticks every time you need to use this, and this thing I came up with only needs only takes 1 tick every time, because it goes through this guy and then it goes straight to the redstone line. That can also be here for better signal strength, and on the other way around, the signal basically cannot do anything and lock itself. And yeah, this is faster and really good. Just to mention this. Alright guys, now that you know how to build it, maybe you want to know how this entire thing works. So for the red circuit, what goes on is, considering the green blocks are blocks of data that we can set, here all it does is it sends an active bit represented by the white block followed by data. That's all. And this one has a much simpler receiver, and it's a lot simpler to expand because it sends this instead as the synchronization thing. So, and what this is 2 active bits making a effective 2-tick pulse because they merge, remember this, and a gap here represented by a 0, and when the redstone dust turns off, followed by the data bits. And what this does is, once the first 2 tick pulse gets in here, it's enough to turn off this comparator, so it kills the latch. So basically, this is now all those repeaters are unlocked now. So after waiting for a extra tick, because we need because of this repeater, we need the data section, the data latches, to not be contaminated by the synchronization pulse. We start sending all the green bits, or the data. The data is able to pass through these repeaters every tick. And after a specified amount of time, we just lock all the repeaters at the same time, and all the data will be in place. Alright, this should be exciting. It's time to expand this thing to a crazy size. So what I'm going to do here is maybe cover some of these blocks, and we're going to copy over the structure and show you how to expand everything. So I'll expand from here, so I will use a mod for this to make my life easier. So this should work, and let's expand this 30 times. So we already have 2 in here, so this should be a total of 32. Of course, this redstone line is not going to be enough, so what we're going to do is to fix this. We can maybe disconnect this circuit and use this to find where we need to do the connection. So once you find a signal strength level of 0, you need to place 1 repeater, and then to compensate for that, we just place redstone dust in here. And what this does is, like, this redstone dust will power this and this at the same time. So those 2 guys will be activated at the same time. To compensate for this, and so they have a tick in between them, we place a repeater. So we do the same thing again. Find where it goes to 0, and break this and replace with redstone dust. Once again. So here again. Redstone block, and will this reach? Barely. It's probably a signal strength level 1, because this would be 0 already. We don't need this guy. And the transmitter is done, guys. This is all we need. The receiver is a little bit more complicated, so let's start by expanding this, I guess from here. So we have to stack this 31 times, I guess. Okay, so this should be 32. So on this side, this is the signal that's going to die, because this signal is going to be renewed every tick. So we find where it goes to 0, place a block, repeater, and another block. And this keeps everything consistent, because now we're going to find a place where we can place another block. We cannot have a block in here, for example, because this wire will not connect without doing something like this. So, okay, block, repeater, and block, and once again block, repeater, repeater, and block. And can we reach? Apparently yes, all of those are powered. Okay, so this has a difference of 1 tick, so we can't afford having those repeaters in here. So because we add 1 tick in here, we need to compensate everything before that, so we place 1 tick in all of those. Okay, and we also added 1 tick here, so all of those guys also need 1 tick from that one guy plus 1 tick from this one. So instead of 2 ticks, those are going to become repeaters on 3 ticks. This is pretty easy to fix. And now this is also in 3 ticks. Let's make sure that this one is also on 2 ticks and this is on 3. Okay. And now all these ones, yes, all those ones are going to be set on 4 ticks. Okay, so now everything's compensated for. Okay, so now let's set a input in here. So maybe let's set the first bit and the last bit. And this, just so you know that I'm not joking about, let's place a gap and have 2 bits and 2 gaps and have 3 bits and 3 gaps and have 4 bits. And now let's do an alternating pattern. So 0, 1, 0, 1, 0, 1. Okay, so we should be able to remember this pattern on the other side. So let's connect both sides and send the information. This should be a little bit laggy because of the light updates. Oh man, I completely forgot to show you this. Yes, you also need to reconfigure this thing, and this is not going to be pretty redstone. So let's make it ugly and functional because that's what matters. So we need, it's 32 bits, so we need to add 32 in here. Maybe we should get rid of this as well. I'm not sure how big this should be, so let's start adding delay in here. So 4, 8, 12, 16, 20, 24, 28, 32, and we have to restore that one. So maybe we can place another one here, get rid of this one. This doesn't make a single difference. And okay, maybe we can use solid blocks in there. Okay, so we have a delay of 32. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So perfect. And now here, because we added 3 ticks, we need to add 3 ticks after this guy in here. So I will remove this as well and add 4 ticks. This is not going to be pretty, but what can we do, right? Maybe like this. So 1, 2, 3 ticks that we added, and then we place back the repeater that we had before. So my dream is to be able to do something like this. But unfortunately, if we do this, because of the bugs in Minecraft, all the bits will merge. This will break the system entirely. So in between each repeater, unfortunately, we need redstone dust, guys. There's no way around it if you want your system to work. Okay, so let's test this thing. Let's send the information. Now it should be a little bit laggy. It's all going in, and it's done. So let's go on the other side and check. Okay, we have 2 bits in there. What is wrong? All right, I just checked. I stacked 1 extra. I did my counting wrong when I executed the command. You can see that we have the first bit there and the other bit in here exactly as I told you. I didn't change anything. So we had a 1 followed by a gap of 1, a 2 followed by a gap of 2, 3 followed by a gap of 3, then 4, then 0, 1, 0, 1, 0, 1, 0, 1. Okay, I can send it again in case you don't believe me. It worked first time, guys. I'm not joking. I just did the command wrong there. So let's see again. And 1 gap of 1, 2 gap of 2, 3 gap of 3, 4, and 0, 1, 0, 1, 0, 1, 0, 1, and then in the end we find another bit. So this is a 32-bit serial transmitter, guys. How crazy is this? And how simple is the circuit? How simple is the concept, guys? Oh yeah, man. I'm so happy with this, and I have so many plans for this. Okay, guys, this video is already too long, but I will try to squeeze in a quick explanation for the application, the last application, as I promised. So let's go there. Oh, this is so amazing, guys. It's rendering the image, guys. A barrier block. Okay, so what's the difference in here? So you can see that I keep all the hoppers locked, and when we give the pulse, we basically unpower all the hoppers for a brief moment. So if the hopper is locked, it's not going to change and not going to send a signal to the observer. But if it's unlocked because of flipped the lever, then it's going to send a signal. So it's a 2-dimensional version of it. So I start by sending, let's check in here. I start by sending a signal to this comparator, which means we read this line at the bottom first. Then we add some delay. All this thing here is to add delay. So we send the signal to the bottom portion of the circuit, then we use those torches to climb up, and then we send the same signal to the next line, and then to the next line, and so on. So since this uses 5 bits per row, the delay is 5 ticks. This is so simple because it transmits 1 bit per tick, guys. It's also actually really amazing. So wait 5 ticks, activate the next section. Wait 5 ticks, activate the next section, and so on. So if you change this, for instance, to a 8x8 panel, you'll just need to, instead of waiting for 1, 2, 3, 4, 5 bits. For 5 ticks, you just wait 8 ticks, and you rebuild this section in here. So now I need to make sure that this signal strength doesn't die, and for that we can apply the same techniques that I showed you for the expansion of the transmitter by replacing this. So if I can copy this, place a repeater in here, and then replace this guy there. So just like this. Then we send all the signals to this side, and we try to merge them. So when the signal gets in here, it goes to this column, so they all can be captured by this repeater, then goes back down in here, and then it joins the rest of the signal in one line, and then goes all the way to the back here. So you can see that on this circuit, the receiver has an extra bit, which is this pair of comparators, and that's because the way of the screen is rendering the pixels requires some extra effort. By the extra effort, I mean, let me see if I'm able to explain. So first, the bits are going to need to fill up the memory at the bottom. Then it's going to work on this section of the memory, and so on. So what I do here is I let all the 5x5 or 5x5 panel comes, which means all the 25 bits come through, and we here we create I don't even know where it's happening. We create a 5-tick pulse. The 5-tick pulse will enable this line, or said other way, it will unlock the repeaters for 5 ticks and lock them again. So any data coming in will be ignored by this line. And using the same principle with the torches, you know, torch up, torch up, torch up, we now do the same thing here. Unlock for 5 ticks, lock back again. Unlock for 5 ticks, lock back again. And this is what gives the animation that you see on the screen when the image is being formed. And yeah, so we need this extender here because all the time the bits are passing through here. Sometimes they will unlock the latch again because they kill this comparator there. So after 5 ticks, we just need to make sure that this signal doesn't disable again. I feel like this wasn't the best explanation that I could give to you guys, but I feel like you can understand by yourself what I'm trying to say. And this makes everything very simple. So this is just an input line, memory section, and then input mapper or output mapper. And yeah, with all that I explained, I believe that I don't need too much to explain in here. Now you should be able to know what's going on in here. Anyways, there's a map download in the video description with all the examples, including the first one that I gave on my past video, guys. So this was a long video, but I hope that I was able to entertain you guys. So thank you very much for watching, and hope to see you back soon, guys. Bye.